You open your physics paper, you see a standard energy question, you write down an answer that feels completely right, and you confidently move on. But without even realizing it, you've just walked straight into a checkmate. Today, we're dissecting an exam trap that silently costs Cambridge IGCSE physics students critical grades every single year.
Look closely at this comparison. I mean, you might look at the answer on the left and think, yeah, that's perfectly fine. The student mentions energy transferring, they throw in some numbers from the prompt, and they get a final mathematical value. It looks like physics, right? But on the right side, a giant, brutal red 0 marks. The examiner has just set a 3-move trap that completely obliterates your method marks. And the scariest part? If you don't know exactly what they're looking for, you literally won't even realize you made a mistake until results day.
This is an incredibly painful mistake to make because it leads directly to grade boundary risks. We're talking about potentially dropping from an A star to an A, or a B to a C, even when you actually understand the core physics concepts. It's a massive confidence shock. You walk out of the exam hall thinking you completely nailed it, but the problem wasn't your fundamental knowledge. The problem was your execution on the page and, crucially, your awareness of the command words.
Now, this right here shows exactly why ordinary revision fails. Notice how Chapter 6 in the syllabus is entirely dedicated to energy stores and transfers, and then we have a completely separate section, Chapter 8, dedicated to work and power. The trap springs because students tend to blur these two distinct chapters together in their minds under the general, fuzzy umbrella of just energy. They end up treating a qualitative energy store question like a mechanical work calculation or vice versa, completely mixing up the terminology and the required math.
So, to stop hemorrhaging these crucial marks, you absolutely must build a clear mental wall between these boundaries. On one side, you've got the conservation of energy stores. That's the fundamental idea that energy cannot be created or destroyed, right? It just shifts, say from a kinetic store to a thermal store. But on the other side, you have the actual mathematical calculation of work and power. That deals with forces acting over specific distances and the precise rate of that energy transfer. Mixing the vocabulary of these two distinct concepts, that is exactly what summons the examiner's red pen.
The ultimate fix is applying this 4-step master framework to every single high-mark energy question you face. Step 1, isolate the concept. Are we talking stores, or are we talking work? Step 2, extract the evidence or data directly from the prompt. Step 3, apply rigorous scientific reasoning. And Step 4, honestly the most critical one for IGCSE, use precise examiner wording. If you skip any of these 4 steps, you're leaving a massive gap in your logic that the examiner is basically forced to penalize.
Section 1. Spot the error. Let's see this in action.
Let's put this framework to the test right now. I want you to actively engage with this as if you were sitting in the exam hall, clock ticking. Read the sample calculation here. They've calculated the transfer, they've written down a formula, and they've arrived at a conclusion. But there's a fatal flaw hiding in plain sight. Take a few seconds, pause, and predict. Do you see the exact mistake? In just a moment, I'm going to show you the exact examiner clue that changes this answer completely. But first, you really need the framework that makes that clue obvious. Because without it, you're just endlessly memorizing corrections instead of actually understanding the underlying mechanics of a perfect answer. Okay, so if your analysis of that previous answer involved any of these common mistakes, you unfortunately fell for the trap. The examiner's red pen strikes most frequently from missing units at the end of a calculation, rounding way too early in the intermediate steps, plugging in the wrong variables like, using mass instead of weight in a potential energy calculation, and giving vague explanations that lack the specific scientific terminology Cambridge demands. And this brilliantly illustrates how we step through our framework to rescue those lost method marks. First, we identify the exact store transfer happening. Second, we insert our substituted values. And, this is key, we explicitly carry the units through the calculation. Third, we state the law being applied, like the conservation of energy. Finally, we lock it in with exam-safe terms. We drop vague, conversational words like moving energy, and instead use precise phrases like mechanically transferred to a kinetic store. Notice how the flawed answer on the left just completely crumbles under scrutiny? It rounds the intermediate value way too early, which throws off the final result by a critical margin, and it completely forgets to include the final joules unit. Now look at the improved top band answer on the right. It's beautiful. It perfectly fulfills the command word requirements, it states the proper formula right at the top, shows the exact substituted values in the next line, delays all rounding until the very last step, and prominently displays the correct final units. That step-by-step clarity is exactly how you secure full marks. A final practical check is absolutely vital for these physics calculations. Never, ever round too early.
Seeing a large, red 0.0 on a return exam paper is often the heartbreaking result of a capable student who thoroughly understood the physics but lost out entirely on significant figures. Always verify your sig figs, double-check your units one last time, and take a brief step back to ask yourself about the reasonableness of your final data. Actually think about it. Does a small toy car really have a billion joules of kinetic energy? Probably not. Catching those simple, unforced errors literally saves your grade.
Returning to the syllabus layout for a second, you can see how mastering this framework for energy stores is actually a strategic long-term move. These concepts of energy transfer don't just magically disappear after Chapter 8. They are the absolute foundation that prepares you for the kinetic particle model in Chapter 9 and the thermal properties of matter in Chapters 10 and 11. If you can format an energy calculation perfectly right now, you are going to absolutely crush the much more complex specific heat capacity calculations later on.
Ultimately, beating the examiner's trap comes down to exact, exam-safe wording backed by correctly formatted data. As this quote perfectly summarizes, your knowledge needs structure to be rewarded. You must consistently provide the examiner with the specific correct terminology, the clear substituted values complete with their appropriate units, and the exact exam-safe wording they are actively scanning the page to find.
So, you now have the master framework for explanations and calculations. You know exactly how to avoid the unit traps, the vague wording, and those pesky early rounding errors. But what happens when you have to tackle the absolute hardest skill on the entire paper? Top band evaluations of complex practical investigations. What happens when you have to analyze experimental design, identify anomalous data, and assess uncertainty?
If a simple energy calculation can silently trap so many capable physics students, just imagine the pitfalls waiting for you in a complex 6-mark practical evaluation. Checkmate is in the next explainer. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. The exact correct answer pathway for top band evaluations is a mandatory next step, so click the explainer on your screen right now to complete your exam strategy.